Hello and welcome back to Trig Review. This is the part 3, I believe, of the Trig Review. We are going to talk about graphs of trigonometric functions. We have 6 of them. Then we are going to talk about shifting and moving those functions. And then we are going to talk about inverse functions. And then we're going to go for lunch, right? Because by that time it will be already 12. No, not midnight if you're watching this from the other side of the planet. So we start by understanding that every relation we write down is followed by a graph. If you write y equal mx plus b, so let's say y equals 2x minus 3, you can draw a straight line. Y equals x squared, you have parabola. X squared plus y squared equals to 9 is a circle radius 3. So it doesn't necessarily need to be a function in order for us to have a graph. So trigonometric functions, all 6 of them, will have the graphs associated with them. And it's going to be the same as any other function you considered before. You learn the default graph, which you can obtain by calculating values. And once you learn the default graph, you can, using 1.6, shift that graph left, right, up, down, stretch, shrink, and reflect on any of the axes. So we start by understanding that the function f of x equal sine x is the actually function which has x as the input domain. So domain will have all real numbers from negative infinity to positive infinity, and the range for sine and also cosine function is going to be from -1 to 1 inclusive. So any value that you plug in into sine x will result in some answer that is between -1 and 1. So you can plug those answers in, because we know that, right, sine of an angle is equal to a number. You can plug in either angle in radians or angle in degrees, and we are going to obtain the same answer on the other side as the f of x. So if you plug in, let's say, sine of 30 degrees, you know the chart from yesterday, you get 1/2. Or equivalently, you can say sine of pi over 6, which is also 30 degrees, and you will get 1/2. Now this means that you have pi over 6, comma, 1/2 as a point that you are supposed to graph. Now you know that pi is approximately 3.14, and then you can divide it by 6 and you can graph that point. So you can compute point by point, right? Sine of 0 is 0, sine of pi over 6, pi over 4, pi over 3, and pi over 2, and so on. And as you plot all of those points onto a graph, you come up with this basic graph, which I'm not drawing to scale, but we are just going to at least take a look at the shape of the graph. If you were looking at this to be the scale, then I would have to go 3 units and then 3.14 units on the x-axis, because this is supposed to be pi, supposed to be 2 pi, pi over 2 for the max. Oh, come on, start thinking. So we have the graph, which is the sine wave. We have our standard x and the y-axis, highest points to be 1, lowest point to be -1, and we go for the full period from 0 to 2 pi. Now, the graph doesn't stop here. We know that it's infinite domain, which means that this wave will repeat itself infinitely many times to the left and to the right, and it will continue on and on and on forever. So we have, let me actually do this. So we have this one. So it will go again into the next. Oh, I missed. Here, 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 going on. So this is 3 pi, 4 pi, this is x-axis. And it will do the same thing on the left. Having negative pi, negative 2 pi, and so on. So this is the basic sine graph, which is infinite to the left and to the right, and it goes between -1 and 1. Now, generally, when we graph sine x, we would say graph one period. Sometimes people will even say one oscillation, one period, graph one period of f of x equals sine x, in which case all you're going to do is this all the way to 2 pi and be done. So if you want to graph one period, you will just show the principal period, which is the first squiggle, and you will stop. Now, what is period? Period is one full oscillation. Now that full oscillation is going to be exactly what I had. So again, the same graph. So this is one full period of sine. And as you can see, in this case, p is equal to 2 pi. This is the basic period of sine function. Again, goes up to 1, down to -1. It has this start point, which I generally label as SP, and the end point, which I label as EP. We don't care about the midpoint for sines and cosines. We will care about those for tangent and cotangent later on, and secant, cosecant, but we'll cross that bridge when we get there. So now we would like to, oh, one more. This is called the amplitude. So from 0 to the max point is the amplitude, and from the 0 to the min point is also amplitude. So the entire height of this wave is 2 amplitudes. So min to max equals 2 amplitudes, because amplitude is measured from x-axis to either min or a max. So you have 2 amplitudes from there. And now that you have all of these things, we write the formula, the general formula, y equals a sine bx minus c plus d. And I will put this one in a box. And once you have this, here we go. Amplitude related to period this is shift left, right, and finally shift up, down. You know what, I'm gonna change this shift left, right into related to. Because if you see there negative pi over 4, it's not going to be shifted pi over 4. We'll see why and how. So this is your equation. You've seen, we didn't label it this way before, but you've seen all of the features of this formula before. You can also put plus and minus in front of A, which will give us the flip on the x-axis, because there will be minus sign on y, which is the x-axis reflection. So we haven't described as a formula any of the previous 1.6 excursions, right, where we had shift exponential, shift logarithmic, or quadratic, whatever. We did not write the formula like this, but for trig it's very useful, and then a lot of applications in terms of word problems later on, and also in calculus, you benefit from knowing this type of a formula. Now, I am going to write on a side my favorite DifEq, and I'll say for graphing. You know how I told you earlier, if you have multiple shifts from 1.6 applied to your function, and that also included logs and exponentials, do the reflection first. Well, for trig functions, you see these letters A, B, C, and D, and DifEq is the order in which you will deal with these letters. So you will first figure out the shift up and down to give you the middle line, and then you will deal with the amplitude to create top and the bottom. Then you will use B and C to box it off on the sides, and you will be able. So in this case, the reflection is actually going to be the last thing you do for trig. So all other functions that we studied, you do the reflection first. You draw the vanilla graph, and then you do the reflection, and then you go and you do whatever else you need to do as you transform graph from one to another. There will be no transforming graph, drawing this 60 times like before. We are going to actually construct the graph of sine immediately in the box. So we are going to use information given to get a box in which the graph fits. So let's work on the example. We're going to start slow and upgrade. So first example, y equals 2 sine of, let's say, x minus 3. So as you can see, I do not have b and c. So in this case, no bc mods. All right, mods, modifications. So all we have is A and D. So we start slow.
Is it helpful in any way to think that B is 1 in the second thing?
Yeah.
Yes, B is 1. Yeah, but we didn't change B from being 1. So that's what I meant. No BC. Yes, B is 1. In A is 2, B is 1, C is 0. I mean, it's not present, but still it's there as a value if you want to think of it that way. And then D is negative 3. So I said DifEq. So what we are going to do, and you immediately start drawing, and then you do some side calculations when you have to. So we're going to draw only one box. I'm going to raise the x-axis higher because of the negative 3, right? It's going to go below. Negative 3, you know it pushes the function down, so no one cares that we haven't done this before, right? All right, so what am I going to do now? Well, my midline used to be at the x-axis, but now that midline is shifted 3 units down. Guys, midline is not horizontal asymptote. Midline is just a midline that will have amplitude up and amplitude down for the whole trig function. And that one is down at -3. So if I want to keep my units as before, I will use 2 squares in this case to get to -3. And that is when, let me use green for instance, I will draw my midline. And that's my midline. What it means is that the graph is going to do this, right? That's the midline. That's why I have midline. So D is done. I did D. I'll cross it off. The next part is to use amplitude, so A, and A is equal to 2. So now from the midline, you will count 2 units up and 2 units down. Let's use red for that. So 2 units going up will give me this upper bound line, the red line, and then 2 units down will give me the lower line like this. And I'm going to cross A with red because I'm done with that as well. So -1 and -2, -3, -4, and -5. So I already have this confined to a box. And now I have to go and look at BC. Now, when I said no BC mods, that means that, yeah, B and C are still present. B is 1, C is 0, but there's no mod on it, which means those are the default values. Now, default values means that it goes from 0 to 2 pi. If I change B, it's going to either squish it or stretch it. And if I change C, it's going to shift left and right. None of those are changed in our case, so my blue sides are going to be standard 0 and 2 pi. So BC, since there are no mods, are going to be 0 and 2 pi. And these guys are your starting point SP and your end point EP. And let's see, I have my standard pi over 2, pi, 3 pi over 2, and 2 pi. So I get my box at 2 pi. So I hope you see that that it's very structured work to block off the area, the space in which this graph would fit. And then you are going to put the starting dot. All of the sine functions start at the origin. Now origin is shifted down to -3. Then it's going to rise up because there was no negative sign to flip it. It's going to fall back into the middle line, go down to min, and go back endpoint on the midline. And then you just draw sine curve. Now labeling the rest of the points. The sine curve is terrible because at the point I was drawing it, this thing happened and some stuff got erased and then I got annoyed. So let's try again. Somewhat better. Make sure these are not spikes, you know, like that. Make sure they are curved. You know, there's a difference between absolute value and x squared. So don't draw your sine graphs like this because it's not that.
Can you mark up the x-axis again for us?
Now we are going to mark everything up, yes.
Okay.
So on x-axis, you first go 0 to 2 pi, and then you say the middle is pi, the half of that is pi over 2, and over here 3 pi over 2 as half between pi and 2 pi. You can always find middle by simply averaging the numbers. right? You go pi plus 2 pi divided by 2 for the average, and you see 3 pi over 2. We are responsible to label these 5 points. The first one is -3, so we see that one. This one is pi over 2, -1. This one is pi and -3. This one is 3 pi over 2 and -5. And the last one is 2 pi and -3. And there we have it. So it's very structured. We use D to put the middle line, which is green. Then we use A to, from the middle line, go up A amount of units and down A amount of units. So 2 amplitude, one goes up, one goes down, to create red lines. And then you will use the blue to do the sidelines, which is start point, end point. And at that point, you boxed off the area where the graph goes. You just need to fit the graph inside the box. So what we do is another example. And we're going to get them to be spicier as we go along. Oh, that's what f of x disappeared here. There we go. Oh, the software went crazy, and I guess just erasing these arrows and then erasing this box and then replacing the box, which is interesting. I mean, I did not have these issues on Windows 8, 8.1. But the OneNote just won't work very nicely with Windows 10. I'm not sure why. I have all of these desync issues and stuff shifting, and it never crashed. OneNote never crashed. I used for a year and a half, or almost 2 years. I used OneNote on Surface Pro 3. On 8.1 Windows, it never crashed. I got Windows 10 with the Surface Pro 4. It keeps crashing, it keeps desyncing, it keeps erasing stuff I write, and it gets to be really annoying. I constantly have to go back and check. So now, as you've seen, they moved all of this red writing up. I guess the updates in the future will fix that. Spicier case. Not the most spicy, right? Because the most spicy case that we can have is, let's say, -3 sine of, 1/2 x minus pi over 4 plus 2, right? So that's all 5 things listed. So let's do an additional thing. Yes?
If the negative sign is before the A, then that's the x reflection. And
yes.
If the negative sign
yes.
is before the B, it's a y.
Yes. Y equals sine of 1/2 x plus 2. Well, so specs on this problem are A equals 1, B equals 1/2, C equals 0, and D is equal to 2, and we still have our dubg to worry about in terms of order to get the box done. Now it's +2, so graph will shift up 2 units, so we are going to leave a lot of space above x-axis and put x-axis somewhere down. Now I'm going to say 1, 2, 3, 4 on the y-axis and start with our D which was green earlier, right? So that's this plus 2. So my midline is at 2. And D is done. Amplitude is 1, right? In front of sine there is 1. So we are going to draw amplitude of 1 above and below green line, and then that takes care of A, which is the amplitude. Very structured, guys. You start with D. If there is no D, then it's the x-axis, its origin. It's not shifted up or down, so your midline is x-axis. But if you have D, your D will be whatever, your midline is whatever that number says it is. So in this case, we have plus 2. Therefore, we go up 2 units from x-axis for midline, and then A is 1 in front of sine, therefore 1 unit above and 1 unit below, 2 amplitudes, right? 1 up, 1 down, to create upper and lower bounds for our box. And now we get to a situation to figure out this 1/2 x. Now, we immediately notice that there is no C. If there is no C, that means that the graph is not shifted left or right, which means that the graph still has to start on the y-axis. We know the start point is at 0, 2. So start point SP is at 0, 2, because no C, no shift left or right. So it has to start where every sine graph starts, which is at the origin. Now remember, your origin is moved to the green height. So now we have that, and at this point I need to calculate the new period, and that is going to be our new stuff. So new period, because B is equal to 1/2. So how do you calculate new period? Well, the formula, remember what I said up there? I said related to period. The B is related to period. So the formula that relates the two is that period is equal to 2 pi over B. That's the formula. So period in this case is 2 pi divided by 1/2, which is 4 pi. That means this function is going to get stretched. It's going to be twice as long as it used to be. Our calculation shows that the period is 4 pi. So it's going to start at 0, which is 0, 2, and then it's going to end at 4 pi 2. So here we go. We used pi over 2 and then pi. Ooh, it's not gonna fit nicely, huh? Oh well, let's use this pi, 2 pi, 3 pi, and 4 pi. So these divisions used to be earlier pi over 2 and then pi, but now we have to end at 4 pi. So here is the blue line on the right to tell us where to end. The function is not flipped, which means it's going to go up at pi, middle at 2 pi, down at 3 pi, back to the green line, midline at 0. It has to be a squiggle oscillation, guys. It has to be that, because that is what sine is. Every sine starts at the midline, goes up and down. Every negative sine will start at the midline, go down and then up and then back to the midline. So positive and negative signs will always be these squiggles that start at the origin. And then you move that origin to the green line whenever you need to. So now we go up, we go down, and then back up again. Label all of the points pi comma 3, 2 pi comma 2, 3 pi comma 1, and 4 pi comma 2 as our graph. It is very structured. Oh, by the way, what is calculus problem going to look like for your graphing? Well, it's going to look like sine squared x minus 3, or it's going to look like sine of ln x squared. That's what the calculus one looks like at the chapter 4. So you need to learn the basic ones. If this looks complicated right now, you have to understand that this is just applying 1.6 to sine to trig functions. Any of the function composition things, like you see me throwing squares and ln's and stuff like that, all of that stuff is actually calculus graphing that you learn in chapter 4. So we are learning or reviewing the basic shifts left and right. And the sooner you learn, right, the order, and the more you practice, obviously everything else later will be much faster. I want to work on C now, and C is the one that it's most annoying, obviously. So let's go with y equals to how about the half on amplitude this time, because we can. Sine of, let's go with x minus pi over 4. And you know what? Let's leave d out of the picture. So d is 0, so green line is on our midline on x-axis. So again, what are the specs? A is a half, b is equal to 1, c is equal to positive pi over 4. We actually are not going to use this c, but I mean, extracted. We're going to use it as the whole thing like this. But, and then d is equal to 0. And we have our DifEq. Maybe I can try it. Let's go this way. DifEq right there. Perfect. I'm going to be now drawing the x-axis in the middle, because there is no d, which means that the graph is going to be symmetric on the x-axis, not going up, not going down. So I have, you know, 1 and negative 1 going up and down. Great. So d is equal to 0. That means that my green line is the x-axis. And then I have a is equal to half. So that gives me the red, half a unit up and half a unit down. It's very narrow. So I am done with A and D. Now B. What I need to know for B is that period is still 2 pi because B was 1. You want to use the formula? Sure, go ahead. 2 pi divided by B, which is 1, is just 2 pi. So period did not change. What did change is C. And to calculate your start point, you will take x minus pi over 4 and set it equal to 0. And you get that x is pi over 4. To do the end point, common sense would say you take the start point plus the period, right, to get the end point. So pi over 4 plus 2 pi will give us, right, this is over 4, 8, 9 pi over 4. So generally this is where people start freaking out because, oh, I have to graph these 4s. Generally what I say, I don't care even if they are pizza slices. Can you count to 9? If you're able to count to 9, you'll be fine. No one said that you have to partition your x-axis in pi's. You can partition them in pi over 2s, in pi over 4s, in pi over 12ths, whatever the problem requires. So I'm going to start my green line over here on the right, and I'm going to label that as pi over 4. And all I'm going to do now is put 9 tick marks to the right to get to 9 pi. So here is my 2, 3, 4, 5, 6, 8, 9. There we go. That's how I count. 6, 8, 9. That's it. No 7s. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That's it. 9 pi over 4. Notice that I never put any pi over 2, none of that stuff, because I don't need them. My start point is at pi over 4. That's where the universe begins for this graph, and it ends at 9 pi over 4. All I need to do now is to just go half, half, half. So between pi over 4 and 9 pi over 4, this tick mark over here is the half, and that's at 2, 3, 4, 5. So that's 5 pi over 4, that tick mark right there. And then halfway between the start and the end is this tick mark here, and that is 3 pi over 4. And then half between 5 and 9 is this one over here, which is 7 pi over 4. All I did is counting and averaging. So, go back to black to draw the function. Go from the origin up into maximum, fall down into minimum, and then rise back up to the midline. And there is your 1 period of the function, and this one is shifted. Now you will say, that's pretty easy because pi over 4 over there, and then you have a pi over 4 over here, so yeah, it's shift to the right pi over 4. Yeah, it is shift to the right pi over 4, but only if this is 1. The next example, I'm going to keep this as pi over 4. I'm going to toss in a 2 over here, and you will see that the shift is no longer pi over 4. So, catch up on this example, meditate, reflect a little bit. Actually, you know what? We did fine so far. How about you work out one and then we'll get the diabolical questions going. So, what is good? How about y equals 3 sine of 2x, so no c. This is just for you to practice the basics. So y equals 3 sine 2x minus 1. So try this one on your own. I'm going to just write it here real quick. Y equals 3 sine 2x minus 1. 3 sine 2x minus 1. I'm trying to squeeze so you can see the previous example at least a little bit. So try working this out on your own. Good. Right. Let's talk about this problem together. Again, we are going to do this problem very structured like the previous example. We're going to create the box. First, we read the specs. We compare it to... Come on, pen. Wake up. Wee. I guess it's time to change the battery. New battery. There we go. Oh, by the way, if you take one of those 9-volt batteries apart, you get 6 of these. You know? But you don't use these for anything else other than these pens. These are quadruple A, 4A. Or you can spend $100 for a pack of 5. It's always, nah, it's not 100. About $6. If it was Apple, it would be 100. All right. Garbage. All right. We go and talk about our comparison to the standard formula. We see that A is equal to 3, B is equal to 2, C is 0, and D is -1. And when I write DifEq is the order in which I'm going to use these letters. So I will, first I scout that the amplitude is 3, and then this is, D is -1, so we'll need quite a tall graph over here, or maybe we can use 1 unit actually, instead of 2 units. And then we're going to go x-axis out. So we start with D. Remember I use green, so -1. So that's my middle line. That's the midline, that's green. Then I have red for amplitude. Count from the middle line, 3 units up, 3 units down. So 1, 2, 3 units up for the upper bound, and then 1, 2, 3 units down for the lower bound to get our box going. And then we are going to calculate the new period. So period is 2 pi over b, which is 2 pi over 2. So the new period is pi. Now starting point is still 0 because no c, right? So to get our left and right bounds for the blue, we use 0, and then you can put pi whatever you want. So generally I like to use the divisions that are, you know, even. So I count 8 squares. That's the best. 1, 2, 3, 4, 5, 6, 7. I do 8 squares because that's the best for a period. I don't care what the period is. I just use 8 squares when I draw stuff. So now, where are the points? Start point for the sine has to be at the origin. Now that's the green line which is moved. And it has to end on the green line. Halfway cuts through the green line as well. Half of the half and another half of another half. And we have that. Now, again, it was positive, so it goes up. It goes down. And then it goes up again. Label points. Now, since the end is pi, then halfway is pi over 2, then halfway is pi over 4, and 3 pi over 4. So what are the points? The first point is pi over, and then I have my 1, 2, 0, -1, -2, -3, and -4. So the first point, the maximum point, is pi over 4, comma 2. Then we have pi over 2, -1. Then we have 3 pi over 4 and -4. And the last point is pi -1. To label all the points. And now let's do the diabolical question. We'll do all 5, including the negative. So this covers everything we learned, all of the transformations we have, and let's do it. So y equals -2 sine of 3x plus pi over 6 minus 1. Down? The problem is... You still do the dump. Now, for this problem, if you're going to try and do it a little bit on your own, at least as much as you can, ignore the negative sign until all the very end. That's where you, instead of putting the points mid, up, mid, you will go mid, down, mid, up, mid. Right? So because it's going to reflect on x-axis. So the minus sign in this case in the front is going to be done last, completely opposite to what we did in PreCalc 1 part, where the reflection was done first all the time. So now it's done last.
So the amplitude is just the absolute value of A, right? As
Yes.
units are concerned.
Yes.
And then
So amplitude is, yes, amplitude is positive 2, so you'll do the green line, 2 up, 2 down. Struggle with the start end point period and all that stuff. And then when it's time to do those points, you will go mid, down, mid, instead of mid, up, mid. catch that or what? Milk, egg, what else is there?
All that you discussed in like chocolate experience in the store and it's the same time. They're gonna get to do it.
You've got the red and green though.
Yeah, I got the red and green one today.
So the next step, if you have your red and green ready to go, the next step is the blue part where you set the parenthesis equal to 0 to calculate your start point. And when you have the start point, you will add the period to calculate the end point, and there are your blues. All right? So read D, that's your green, midline, plus minus 2 for the reds. Set the parenthesis equal to 0 for start point, which is your left blue. You know the period formula, you can calculate the period. So whenever you get the start point plus that period is going to give you the other blue. And you have your box. And then you fit the function inside the box. Make sure you flip it because it's negative. And if you were taking this class, where I'm from, everyone but 2 students would be kicked out of classroom. I would be talking to 2 students. Because you all have lined paper, you don't have a square paper. You're not allowed in the classroom, in the math classroom. If you don't have a square grid paper, you are not allowed in the classroom. And only 2 students in this classroom have it, which is interesting. Yeah. Oh yeah, it helps there. I mean, sure. It's a huge help. First thing, oh, have no square paper? Go outside, play ball. School's not here. All right, so A is 2, and then I write flip so I can remember. B is 3, which immediately tells me that the period is 2 pi over 3. C is negative pi over 6, but we are never going to use it in this form, right? Because we set the whole parenthesis equal to 0. And the D is negative 1, and I need that for the green. So we have 1, negative 2, negative 3. I don't know what we're going to need. We are going to have the green line, midline at negative 1. We are going to have the red lines at 1 and negative 3 because we have to go 2 units from the green line. So we have negative 1, 0, no, positive 1 up there. Negative 1, negative 2, negative 3. That's it. That's x-axis and the y-axis. Oh, that's 3x plus pi over 6 is gonna shift left. I might need more time, more space. Well, we'll see. So to get my start point, I set the whole parenthesis equal to 0, and I get 3x is equal to negative pi over 6, and then I multiply both sides by 1/3 to cancel the 3, so I get negative pi over 18. Yoo-hoo! The divisions are in 18s. No one cares. Can you count to 18? Yeah, you can. There we go. So I'm going to start my box. And I'm going to call this one over here negative pi over 18 because that's my start point. Now I need my end point, and that's going to be negative pi over 18 plus 2 pi over 3. And to find the common denominator, I multiply by 6. So end point is going to be at x negative pi over 18 plus 12 pi over 18. So it works out to be 11 pi over 18. So all I need to do is to count 11 from the origin. So there it is, 11. And the box is complete. So it's very structured. You set the parenthesis equal to 0. That gives you the left blue line, the number you got plus the period you calculated is going to be the right line, and you just make the number of divisions, whatever it needs to be. Now we know it's a sine graph, so it has to start and end on the midline, and the middle of the whole thing is the middle of the graph, so that's here. Since it is negative, we have to flip, so it goes down first and then up. And now we just need to figure out the values. We know that this one over here was the end point, which is 11 pi over 18 comma negative 1. And just count the tick marks for everything else. So we have negative pi over 18 comma negative 1 for the right point. And that's 1, 2, 3, 4, 5 pi over 11 negative 1 for the midpoint. 1, 2 pi over 11 and negative 3 for the minimum, and that's 5, 6, 7 pi over 11 and 1 for the maximum. And I will go to the board and show one more time the way I count. Just make my stick over here. So this one is clear. It's negative pi over 18. So x coordinate is negative pi over 18. Y coordinate is negative 1 because that's the green line. The last point is the end point which we calculated. So 11 pi over 18, negative 1 again on the green line. To calculate this one, you can either average start and end point divided by 2. So negative 1 plus 11 is 10, divided by 2 is 5. Or you can simply count the tick marks. 1, 2, 3, 4, 5. Each tick mark is pi over 11, so you have 5 pi over 11, so 5 pi over 11. And then 5, 6, oh, that's supposed to be 8, not 7. That's a 5, 6, 7, 8. So that's 8 pi, not 7 pi. Sorry. 8 pi over, if you count carefully, 8 pi over 11. And then you have, so that's 8 pi, 9, 10, 11, which is those ones. Over here you have 0, 1, 2, right, which is where the minimum is. Yes?
How did you change from 11 pi over 18 to 5 pi over 11? Would it be over 18?
Yeah, they're all over 18.
Okay.
How? It's magic, okay? That's how. It's all over 18. I have no clue where I started with 11 and why. They are all over 18 because our denominators, our divisions are all in 18. So yes, denominators have to match everywhere. So the basic graph is 0 to 2 pi, and then you have everything else work. Guys, 1 out of 6 done. Excited? I know. Now, what's awesome is that your cosine, secant, and cosecant are all the same. They all fit the same box. They all fit the same rules. So we technically did 4 out of 6. And we just need to take care of the tangent. But before I go to the tangent, cotangent, I want to talk about cosine, secant, and cosecant first to get all of them out of the way. So you know in detail how to get sine graphs, regardless of how complicated they are. And obviously, with practice, you will get better. What is the difference between sine and cosine graph now? Well, for cosine graphs, which is y equals a cosine bx minus c plus d, it's just that the vanilla graph is a wave that starts at 1 rather than origin and does the same thing as sine. Technically, sine and cosine graphs are the same and they are pi over 2 shift, right? But we actually have the cosine graph. So what is the cosine graph? Cosine graph starts at 1, falls at 0 at pi over 2, goes to negative 1 at pi, 3 pi over 2 back at 0, and back at 2 pi back at 1. So this is the principal cosine. Right, that's the cosine. And everything is the same. Formula for the period is still, well, you still do DifEq. Formula for the period is 2 pi over b. Start point, end point, right, work the same. So all of the specs, everything you learned is the same. The difference between sine and cosine graph is when you are ready to graph cosine, instead of starting on the green line, you will start on the upper red line if it's positive a, and the lower right red line if it's a negative cosine. So positive cosine goes like this, and the negative cosine goes like that, right? So we'll do one quick example of, let's say, 2 cosine x minus pi over 3 plus 1, for instance. This is going to be very quick. So I have plus 1 and 2, so we're going to go higher. It's my x, it's my y, my green, so new one is +1. There it is. My red values are 2 up and 2 down, so this is my 2 up and this is my 2 down. The b is equal to 1, so period is 2 pi still. The start point is x minus pi over 3 equals 0. X equals pi over 3. So, and then end point is pi over 3 plus 2 pi. So that's 7 pi over 3. So if I call this pi over 3, so that's 1, 2, 3, 4, 5, 6, 7 pi over 3. The cosine, it's not flipped, so it starts on top and ends on top because it's a positive. Midway is there. And now midway here is there and there. Draw the cosine through these points. And we're done. So now this is pi over 3, 2, 3, 4 pi over 3 and negative 1. And the end point is 7 pi over 3 and positive 3. And the start point is pi over 3 and positive 3. The only ones that are tricky are these ones because they don't fall on pi over 3, but it's okay. Pi over 3 plus 4 pi over 3 divided by 2 is 5 pi over 6 when you average. So 5 pi over 6 and 1. And the second one is 4 pi over 3 plus 7 pi over 3 divided by 2 for the average is 11 pi over 6. So the second point over there is 11 pi over 6 comma 1. And that takes care of a cosine called efficiency. Same rules, same steps, same everything. You have to be careful where you draw your cosine. So I'll start on the board just a catalog of the shapes, basic shapes. So sine starts at the origin, gives you a squiggle like this, and the cosine starts on top, dips down, comes back up at 1 for the cosine. And now we get to secant and cosecant. These graphs freak everyone out, but you know what? They're very easy. What is the secant? It's 1 over cosine. And what is secant? Secant is 1 over cosine. And cosecant is 1 over sine. All you do is you ignore the fact that they are secant and cosecant graphs. You do sine and cosine graphs instead. Then you cut down the green line and you just flip them outwards. That's what you do. So if you have a secant graph, you will ignore that it's a secant graph. You will draw the box and you will do the cosine graph. And then you take the scissors and you cut down the green line and you just flip them out. So let's do that example. Secant or cosecant, it doesn't really matter. Let's do secant because it's off of cosine. So practice another cosine along the way. Oh, no! How much did you erase? I think. There. Y equals secant of, let's say, 1/4 x minus 2. The way we do this is I'm just going to strike the purple and I say cosine, and then we are going to fix that later. So you are focusing on a cosine graph. You're completely ignoring the fact that it's secant for now. And in the end step, you will just flip this thing out. We do the regular steps that we know, nothing special, nothing new. Graph is going to go down, so I need more space below x-axis. We go with green at -2. And then I need my reds 1 unit up and 1 unit down. So those are my reds. Period is 2 pi divided by a quarter, which is 8 pi. Woohoo! And the start point is at 0, because when you set 1/4 x equal to 0, you get 0. So this is a cosine graph which is not flipped. I have 0 and then 1, 2, 3, 4, 5, 6, 7, 8. So the cosine graph needs to fit in this box. Again, red lines are amplitude, blue lines are left and right, start point, end point, and the entire cosine graph fits inside. We start the cosine graph in the upper corner on the left because it is not flipped. We end upper right corner, so upper left, upper right, that's where it starts and ends. Midway is the minimum, and then halfway's on green. I'm going to draw these guys dashed because this is not the graph we want. This is the cosine graph. We want secant graph. Now that I have my cosine graph as a guide, I am going to take scissors and cut along the x. Look at those scissors. It's just right there. All right. You take scissors and you cut along x axis, in this case green axis, and you just flip the stuff out. Now, as you are flipping out these things, the vertical asymptotes will show everywhere where cosine hits through the middle line, through the green line. So now, when you invert this one, it looks like this. You invert this one, goes like that. You invert this one, goes like that. And that is your secant graph. The solid black lines are the secant graph. The dashed line is the corresponding cosine graph, which is 1 over cosine is secant. And remember, anytime when the cosine was 0, because it's 1 over 0, it's undefined, which is the reason why you have vertical asymptote at those places. So wherever sine or cosine graphs cut the green line, midline, that is the location of your vertical asymptotes. And the min and max points are these anchor points which will give rise to these U shapes. Now remember, cosine is actually infinite wave. We drew only one. This wave will go forever, so this is actually a U shape, and another U shape, and another U shape. So both secant and cosecant graphs are infinite series of U shapes, above and below, and they're always shifted. So you have a shape down, shape up, shape down, shape up. They never go on top of each other. It wouldn't be a function, right? Vertical line test. So to get the secant and cosecant graphs, you spend time carefully working on sine and cosine, and then whenever sine and cosine cut the green line, put the vertical asymptotes there, and then just invert the cups. Your min and max values will be the anchor points for these U shapes, and you just go U shape up, U shape down, like parabolas. They're not parabolas, but like parabolas. You just draw a whole bunch of those. So now, corresponding, I should write over here, so this is your sine, this is your cosine, and now you have your cosecant. which would look like this, the U shape up and the U shape down for the cosecant, and observe that this was the maximum for the sine. Maybe I should draw the sine now. So U shape up, U shape down, and you have your secant graph, which corresponds to cosine, one we just did, where you have these puppies, and then you have, so cosine would do this, and you would have your U shape down, U shape up. It was a half a use, but these are the basic four graphs. If you master the sine, everything else is the same. You have an extra step to worry about in each other case. The last creature we need to discuss for graphing is tangent. But let's take a break because we are already 7 minutes over your regular break time. And then when we come back, all we have to take care of are tangent and cotangent. Again, the same rules and for both of those. And then inverse trig, and then go for lunch, I guess. So I'll restart the stream in 5 minutes or so.